Now I want to talk about ethers. And it turns out that in Organic Chemistry 1, you're going to be responsible to know 4 different methods to synthesize them. Some of these methods are going to be stuff that you already know from prior chapters. And some of it is going to be really related to other reactions you've learned. It's just going to be tweaked a little bit, okay? So overall, this isn't so hard. You just have to keep track of the 4 reactions to make ethers. So let's start off with the simplest one, which is called Williamson ether synthesis, which sounds complicated. You're thinking, oh man, another name that I have to memorize. But really, this is an easy reaction. All this is going to be is an SN2 reaction of a primary or a methyl alkyl halide with an oxide base. Okay? Now, this is just a typical SN2 that we would use the flowchart for. So you might be wondering, well, Johnny, why does it have that funky name? Well, Williamson ether synthesis is just the name for that specific route that you take on the flowchart. Cool? So even if you forgot the name of this reaction, you would still know what to do just by using the flowchart. So let's go ahead and talk about SN2 for a second. Remember that, what does SN2 really require? A good backside, right? So that's why primary and methyl alkyl halides are awesome at Williamson ether synthesis because they have a really good backside. Well, what happens if I try to use a secondary or a tertiary alkyl halide instead? Okay, let's say that I'm like, hey, screw the primary alkyl halide, I want to start with my tertiary. Can we do that? No, we can't. Because remember that secondary and tertiary alkyl halides are sterically hindered in the back. So what that means is that they're actually going to favor E2, not SN2. Okay? So now that I've kind of explained the reagents, let's just draw the mechanism. So as you can see, what kind of alkyl halide am I starting off with? This would be primary. What kind of nucleophile do I have? Is it neutral or is it negatively charged? Well, in this case, this is negatively charged because it's going to dissociate into OET negative, okay? So even if you didn't know what this was, we could just use the flowchart. So according to the flowchart, the first question is my nucleophile negative or neutral? It's negative. 2, is it one of my bulky bases? No. 3, what kind of alkyl halide do I have? Primary alkyl halide. Does that always favor a certain reaction? Yes, it favors SN2. So even if you didn't remember that this is Williamson ether synthesis, it's fine because you could just use the flowchart to figure it out, okay? So now we just have to draw the mechanism. The mechanism would be a backside attack. My OET would kick out the BR, and look what I get. I wind up getting a carbon with an O and then an ethyl group on the other side, okay? Now, I'm just replacing the ethyl group. This is the thing that was ET before. I'm just drawing it out, okay? But notice that, look what functional group I have at the end. I have an ether, okay? So I was able to use an SN2 reaction just from the flowchart to make an ether. And this is your first and probably most common form to make ethers in this chapter. Okay? Good so far? Let's go ahead and move on to the second way to make ethers.